cart travels along a frictionless roller coaster track. At position 1, the cart is 10 meters above the ground. What is the velocity at position 2? Okay, so this is a very similar problem to a ball falling through the air. Only difference is really that we're using a cart on a frictionless track. So at position 1, we know we're at a height of 10 meters. At position 2, we're at 0 meters, ground level. And we're looking for the velocity at position 2. So we come to our definition of work, which is the change in kinetic energy plus the change in potential energy. We break that down even further. The change in kinetic energy at position 2 minus change in kinetic energy at position 1. Same thing over here. Change in 2 minus change in 1, only we're doing potential energy. So 1/2 mv squared, 1/2 mass times velocity squared, and then here, mass times gravity times height. So normally it's just mg squared, but in this case, we need to use the height. So I went ahead and put that in there. Okay, once we set these, before we set these equal to 0 and start them for velocity, we have to ask ourselves, is there anything in here that's 0? Our system is Earth and the cart, by the way. Is there anything in here that is 0? The answer is yes. Starting from rest, so position 1, we'll start from rest. So that's 0. The height at position 2 is 0 because we're at ground level. So mass times gravity times height, which is 0, is going to give us another 0. So we come down here, we get this formula: 1/2 mass times velocity squared minus mass times gravity times height. We got to solve for v squared, we solve for v. I just put v squared there. So we come over here, the masses cancel. 1/2 v squared equals gravity times height. V squared equals 2 gravity times height. V equals square root of gravity times height. We go ahead and put in all of our numbers. Square root of 2 times 9.8 times 10 equals 14 meters a second at position